Okay, let's find the volume of the solid region bounded by z equals 2 times x times y above the triangle given by the vertices 1, 1, 3, 1, and 3, 5. So the surface z equals 2xy is going to lie above the triangle given by these vertices. So let's draw the triangle. The interior of this triangle is our region R. So I'm drawing the boundary. The boundary is the triangle. R is the inside of it, right? Okay. So we want to find the volume between this region R, defined by the triangle, and the surface z equals 2 times x times y. How do we do it? Well, first of all, it might be a good idea to set up kind of a template integral here. Just kind of generic. The integrand, except for the integrand, it's going to be specific. It's 2 times x times y. And then dA. We need to decide that the differential dA could go in one of two orders, dy dx or dx dy here. Remember, if you go with dy dx, you're using vertical rectangles, which is pretty much what we use if we can, if we have a vertically simple region, which we do. Look, if you draw a vertical rectangle anywhere, a vertical representative rectangle anywhere inside of R, doesn't matter where, the top and bottom will be given by the same functions. The top and bottom of the rectangle will be given by the same functions. The bottom function is easy to find. It's y equals 1. The top function is a little harder to find. If we fill in the vertices, this is the vertex 3, 5, and this is the vertex down here. It's 3 or 1, 1, 1, I should say. And it is a line, so we can find the equation of the line. It just takes a little longer. First off, let's find the slope. The slope is going to be rise over run. So 5 minus 1 gives you the rise. That's 4. 3 minus 1 gives you the run. That's 2. So the slope, 4 divided by 2 is 2. And then we can use the point slope form, y minus y1 equals m times x minus x1. Fill that in, and we have the equation of our line between 1, 1 and 3, 5. I'll use x1 equals 1 and y1 equals 1. 1, 1 is our x1, y1. So fill in, we get y minus 1 equals 2 times the quantity x minus 1. And if you multiply this out, you get 2x minus 2. But then if you add 1, you get 2x minus 1. Y equals 2x minus 1. So the upper function here is y equals 2x minus 1. The lower function is y equals 1. These represent your lower and upper limits of integration, the right-hand sides of these equations. Inner limits, right? So if we want to fill this template integral in, the inner limits become 1 to 2x minus 1 with a differential order dy dx. And the outer limits of integration, x runs from, what does x run from over the whole region? What's the left-hand most value x can attain? 1. And the right-hand most value x can attain is the x-coordinate of this point, which is 3. So 1 to 3. And so this is going to represent volume. And then you have to be able to evaluate it. So let's evaluate the inner integral first. Integrate 2xy with respect to y. You get 2x times y squared over 2. The 2's will cancel. So we'll get I'll leave the x on the outside and y squared, and then we have to evaluate y squared from 1 to 2x minus 1. And we still have the dx. Again, when you integrate y squared with respect to y, you get y squared over 2, but that 2 canceled with that 2. Okay, so then what do we have? If we apply the fundamental theorem, plug in the 2x minus 1, we get 2x minus 1. Plug that in for y, so we have to square it. Then that's plugging in the upper limit, plug in the lower limit, you get minus 1 squared, which is just minus 1. And before we evaluate this integral, go ahead and multiply this out. We get 4x squared minus 4x plus 1, but that's going to cancel with that minus 1. So we get that. And we should probably, before we try and integrate, we should distribute that x, right? So we get 4x cubed minus 4x squared as our new integrand. And we integrate. Okay, x to the 4th, divide by 4. The 4's cancel. We just get x to the 4th here. Here, it's not so nice. We get minus 4/3 x cubed. So x to the 4th minus 4/3 x cubed. When we integrate 4x cubed minus 4x squared, evaluate from 1 to 3. You get 3 to the 4th. When you plug in the upper limit, you get 3 to the 4th, which is 81, minus 4/3 times 3 cubed, but that's 27. And then subtract off what you get when you plug in 1, which is just 1 minus 4/3. When you plug in 1 for x, you get 1 here, and then minus 4/3 here. Then we just have to figure out what this is, and we're done. Okay, well this is, whoops, thinking ahead there. 3 goes into 27. 9 times minus 4 times 9, there's your 36. So 81 minus 36. And then this is 3/3 minus 4/3, which is minus 1/3, but a minus makes a plus. So how about plus 1/3? So we get 45. 81 minus 36 is 45 plus 1/3. Or I think 45 is going to be 135 thirds plus 1/3. So 136 thirds is your answer. And that's a volume. So whatever the units are, originally the units of volume will be in cubic units.